So today we're going to be looking at this heating curve here and giving some explanation. The first thing I want to touch on is our starting point down at 30 is where we are going to be heating up but also cooling down. So that's our freezing point. Our heating curve can go in two different directions, whether you're heating up or it's cooling down, so going from a solid to a gas or a gas to a solid. Our first flat line here is going to be our melting point, and then we crawl up when our liquid is heating and we hit our boiling point at our second flat line. This is also our condensing point if you're coming back in the other direction to go back to freezing. And then we hit our freezing point at stage 4 right here with the flat line once again. So melting and freezing are at the same point depending on which direction you're going. And then at 70 degrees Celsius, the liquid is either in the heating or cooling phase, depending once again on which direction you're going. At 90 degrees Celsius, the liquid is considered condensing or boiling, which I just touched on a little bit. Next, we're going to be looking at where the substance only exists as a gas. So that's going to be after that 90 degree mark when we start heading up again right here. Next, question we are presented with is a gaseous sample of the substance has a pressure of 1.2 atoms and a volume of 2.5 liters. If the pressure is increased to 1.5 atoms, what is the new volume of the gas? And we're going to assume this is at a constant temperature in moles. So this is using Boyle's law, which states that at a constant temperature, the pressure and volume of a gas are inversely proportional. So we're going to use Boyle's law equation to calculate the new volume. We're going to take 1.12 atoms, which is our original volume, our original pressure, and then 2.50 liters, which is the original volume, and divide by 1.50 atoms, which is our new pressure, which gets us to 1.87 liters. And then we're going to use, so our next question is a 0.85 mole sample of the gas has a volume of 1.25 liters. If 0.55 moles of gas are added to the sample, calculate the new volume. To do that, we're going to have to add up our moles to see what our total is at the end. And then we're going to take our liters times our total volume of moles and divide by our original sample, which is gets us out to 2.06 liters. And then for our last question, which is a gaseous sample of 1.65 moles of gas has a temperature of 305 kelvins and a volume of 2.75 liters. What is the pressure of the sample? So let's just list a few things out here. We're going to use ideal gas formula once again. N equals 1.65, T equals temperature equals 3.05 kelvins, and our volume is 2.75. And we need our ideal gas law constant, which is 0.0821 liters. So we're going to multiply our temperature times our ideal gas constant times our times N here, and divide by 2.75 liters, which brings us out to the atmospheric pressure of 15.02.